All right, so to factor some of these, if they are factorable, it says trial and error, but we don't have to do trial and error. You can do bottoms up instead, where you take the front number, the leading coefficient, multiply it to the constant, the back number. So you get -8. And then really we're just looking for two numbers that multiply to be -8 and add to be -7. So as you're going through that, -8, add to be -7, that's probably going to be -8 and +1. -8 plus 1 is -7. All right, since we're doing that bottoms up trick, you have to divide by 2. Since we multiplied it, you have to divide it. You end up getting x minus 4. And then that does not reduce, so bottoms up, 2x plus 1. And you can quick do a little mental FOIL to make sure this worked out. X times 2x is 2x squared. The -4 times +1 would be the -4 in the back. And then that would be 2x. No, not 2x. That would be 1x and -8x, -7. Perfect. All right, for B, it's really the same thing. Except this time when you multiply it, since you get -8, we're looking for multiply to be -8, add to be +7. So that should just switch things around a little bit. We're going to want a +8 and a -1. And then same second step, you've got to divide. Reduce it if you can. And then if you cannot, bottoms up, 2x minus 1. Again, you check that out. You get a 2x squared in the front. You get a -4 in the back. You get an 8x minus 1x. Over here for C, you take the same thing. You're going to multiply the 2 to the back. You get a +8 this time. Multiply to be a +8 and add to be a +7. The only way you get 8 is 8 and 1 or 4 and 2. You cannot get a +7 from that. So you could call it irreducible. You could call it prime, because you can't factor it. That's what prime means, you can't factor it. Or you just simply write out cannot factor. And then for D, I don't like negatives in the front. So the easiest fix is to factor it out. Think of it as a common factor. So you factor out the negative, you get a positive. Take out the negative, you get a positive. Take out the negative from the positive, you get a negative. So now when we do our trick, bottoms up, you're going to multiply the front to the back. You get -8. Two numbers that multiply to be -8 and add to be 7. If you actually look, this is the exact same thing what we did in B. So kind of know what the answer is going to be just with the negative out front. So multiply to be -8, add to be 7. +8 minus 1, so that negative out front. You got to do the bottoms up trick, so divide by 2, reduce it. With the negative out front. Sums and differences of cubes. There's a formula. So when you're doing those, you have to remember the formula, so we'll start with that. So if you're factoring this, I'm going to leave the sign off of it. Whatever those terms are that are being cubed, they go in the front and the back of the first parenthesis. And then the second part, the longer part of the problem, is squared multiplied together, squared. Square multiply square. I'll rewrite that so you can read it. And then to remember the signs, the mnemonic SOAP will help you. So whatever the sign is, if it's a positive, in these three positions, it's going to be the same sign, the opposite sign, and then this last one will always be positive. So if this was a plus, like it is in example A, it's the same sign, so that would be plus. It's the opposite sign, which would be negative, and then the last one is always positive. So all you got to do with the problem is look to see what is being cubed. So for A, it's an x cubed and a 1 cubed. So x and 1. And then the big trinomial part of our factor is squared. Multiply together. 1 times x is 1x. And then you square. 1 squared is 1. Square, multiply, squared. Square, multiply, squared, which is also the 3-letter thing for text messaging, SMS. So maybe you can remember that. So then you do the sign, or the signs using SOAP. It was a positive, so it's the same, it's opposite, and it's always positive. For B, we got to look at what's being cubed. First, it's an x. And then 216 is 6 cubed. Right? And then the back, the trinomial part, the 3 terms, squared. So x squared. Multiply them together, 6x, and squared. And you go in and fill in the signs. Same sign, so it's positive. Opposite sign, negative, and always positive. For C, you got to look at what's being cubed. That's 10 cubed. And that is 8 you get from doing 2 cubed. X to the 6th you get from x squared cubed. And then our 3 terms you get from doing squared, so that's 100. Multiply them together, 20x squared, and then squared will be 4. X squared squared would be x to the 4th. And then fill in the signs. It's a minus in the problem, so same, opposite, always positive. Last one, what's being cubed? 64, that is 4 cubed. A cubed, that's a cubed. And then an x. 125 is 5 cubed, so that's a 5. And then fill in your 3 terms. If you square 4ax, you get 16 a squared x squared. If you multiply those together, you get 20 ax. And if you square the back, you get 25. And then same, opposite, always positive gives us, starts with a minus, so it's same, opposite, always positive. Another type of factoring is grouping. You group the first 2 terms together and the last 2 terms together. And from each of those groups, you take out the common factor. So x to the 4th, 2x cubed. The common factor is x cubed. So you'd be left over with an x minus 2. Then the common factor between 3x and minus 6, you get 3. Take out the 3 and you're left with x minus 2. Grouping only works when these parentheses here are the exact same. When they're the exact same, that's one of your factors, x minus 2. And then your other factor, your other parenthesis, would be the terms in front that you factored out, the x cubed and the plus 3. This was close. This last little term right here, that was close to being a sum of cubes. So if that were a sum of cubes, you'd have to actually do it. You'd factor it further. But you can't in this case. Sometimes that leftover part, that last part, will be factorable. And B would do pretty much the same thing. Group, and take out common factor. So this has an x in common, so you take out an x, a squared plus b. These are both negatives, so we're going to take out a negative, and they have a z in common. And then we're left with a squared, take out the negative, so that's plus b. The parentheses are the same, so that's a common factor, a squared plus b. And then the factors that we took out, x minus z, is ortho. These are difference of squares and sum of squares. A is a difference of squares, which, in my opinion, are the easiest ones to factor. You've got a perfect square and a perfect square. That's what goes in both parentheses. So the square root of 144 is 12. The square root of x squared is x. That goes in both of these. And then since it's a minus in there, it's a positive and a negative, a plus or a minus. B, this is really just kind of a trick question. When it's a perfect square in the front and the back, the second term is also a perfect square, but it's a plus sign, you cannot factor it. Irreducible, prime, whatever word you want to use. And then C is a little bit tricky. $144 is 12 squared, so we know we get a 12 in the front. It's also a minus in between here, so that means we can do it. The y minus 3 squared means y minus 3 is the part that's being squared. So you're going to have parentheses in parentheses. And then since it was a difference of squares, you get one with a plus, one with a minus, one positive, one negative. But parentheses inside parentheses is not simplified. You need to simplify that a little bit. So you have to distribute whatever's out front, which really means you're just distributing a positive, so that's nothing. Distribute the negative, that does a little something. And now we've got like terms. We can combine the 12 and the minus 3 to make this be y plus 9. And we can combine the 12 and the positive 3 to get 15. We have a negative y. If you wanted to, you could have wrote that the other way, like 9 plus y and 15 minus y. Either one's okay. Whenever there's parentheses, inside the parentheses, you're going to have to simplify that. If there's any like terms, you got to combine them. But the order you write them does not matter at the end. These are essentially the same thing. They are perfect squares, because 4 is a perfect square, a squared is perfect square, b squared is perfect square, 9 is a perfect square, and c squared is a perfect square. So everything in all these problems is a perfect square. But a has a plus sign. You cannot can't factor a sum of squares. Prime is irreducible. Can't factor it. B has a minus in between, so we can factor it. It's a difference of squares. So the first term, that's 2 squared, that's an a squared, and that's a b squared. So it's 2ab. And in the back, that's a 3 and a c. One's positive, one's negative. And for c, same first part, 2ab. It is a minus in between, which means we can do this. And then the 9 means that they each get a 3. And then the ab plus c squared means, since that's what's being squared, they each get an ab plus c. One of them's positive, one of them's negative. And again, we have parentheses inside parentheses. I think we would have some like terms if we multiply this out and combine it. So let's do it. Distribute your positive 3. Plus 3c. And now we're going to distribute the negative 3. And then inside those parentheses, each one we're going to see if we can combine like terms. So 2ab plus 3ab, 5ab. And we have the plus 3c. 2ab minus 3ab would be negative 1ab. minus 3c and there's actually a little bit more factoring we can do with that because this last term, they each have a negative. So we can pull out that negative all the way to the front, and we would have AB plus 3C. That's as far as you can go. There's no more like terms, no more common factors. We're done.